Hey everyone, and welcome to the AI Research Roundup. I'm your host, Alex. Today, we're diving into this post from Google Research titled InstructPipe, Generating Visual Blocks Pipelines with Human Instructions and LLMs. So, this article introduces InstructPipe, a really neat prototype designed to help users build machine learning pipelines visually. It uses, natural language instructions to automatically select and connect the right nodes within a visual programming framework called visual blocks. This aims to make building ML pipelines much easier, especially for beginners. Alright, so this first figure gives us a high-level view of InstructPipe in action. It shows how a user provides an instruction and a tag, like, say, multimodal pipeline to visual blocks. Then, InstructPipe goes to work, selecting and connecting the appropriate nodes, ultimately generating the desired pipeline. It highlights the key components: the node selector, code writer, and code interpreter, making the whole process visually clear. So Figure 2 shows the InstructPipe interface. A user can type in a natural language instruction, like grab sunglasses from the internet, and let me experience virtual try-on. There's also a tag option for added context. This simple prompt, as the caption says, kicks off the automated pipeline generation process within visual blocks. Pretty cool. Okay, so Figure 1 from page 3 visualizes the entire InstructPipe process. It begins with a user providing an instruction and tag in visual blocks. InstructPipe then uses its node selector and code writer, which are LLM modules, to generate pseudocode. A code interpreter then translates this into a usable pipeline displayed back in visual blocks. Well, this figure from page 4 actually shows a practical example of a pipeline within visual blocks. It seems to connect input image, a Pali node, an Imagen node, and finally, an image viewer. So this visualizes how these different nodes, selected by InstructPipe, can be linked together to presumably perform some sort of image processing task. It nicely illustrates the end result of the process described earlier. So this figure shows the pseudocode generated by InstructPipe's code writer. It defines the input, an image and text prompt, the output, an image viewer, and the processing steps using Pali and Imagen. This code essentially represents the connections between nodes, forming the pipeline. This simplified representation is then interpreted and translated into the visual pipeline we saw earlier. Next, this figure details the user study workflow. Participants completed tasks using either InstructPipe or just visual blocks, followed by a NASA TLX workload assessment. This alternating setup allowed researchers to directly compare the two conditions and measure InstructPipe's impact on things like task completion time and perceived effort. This directly relates to the significant improvements mentioned in the summary. And finally, this figure presents the raw NASA TLX results. It uses box plots to compare InstructPipe and standard visual blocks across several workload metrics. We see statistically significant reductions in mental, physical, and temporal demand, as well as effort and frustration when using InstructPipe. This really underscores the improved user experience and reduced workload highlighted earlier. This table presents the median task completion times and number of user interactions from the user study. With InstructPipe, the median time was 203.5 seconds, compared to 304.5 seconds with standard visual blocks. Similarly, InstructPipe saw a median of 5 user interactions versus 16 with visual blocks. The triple asterisks indicate these differences are statistically significant, supporting the previous findings of reduced workload and improved efficiency. This figure showcases a sunglasses try-on demo built within visual blocks. It demonstrates the practical application of InstructPipe, showing the input fields for text and live camera, the generated images of sunglasses, and the virtual try-on result. Below, we see the underlying visual blocks pipeline itself, visually representing the nodes and connections orchestrated by InstructPipe from the simple user prompt. So, wrapping up this look at InstructPipe, it's really impressive how this tool simplifies creating ML pipelines in visual blocks by letting users give instructions in plain language. The key takeaway? InstructPipe significantly lowers the barrier to entry for visual ML programming, making it more accessible and efficient. Alright, thanks for joining me for this AI Research Roundup.